Today we get to talk about one of the great applications of the whole course, and it's the Leontief input-output model in economics. And here's Dr. Leontief, and he won the Nobel Prize for his work in this area. Born in Germany, died in New York, looks like he has a famous daughter, and importantly, he won the Nobel Prize for what we're going to talk about here. So this is interesting. Even though he was born in Germany, I guess he was Russian. So he's an American-Russian economist. He ended up in America eventually. I know he was associated with Harvard at one time. So Leontief was a Russian-American economist known for his research on input-output analysis and how changes in one economic sector may affect other sectors. And when you win the Nobel Prize, you get to do a lot of cool things. One thing you do is you give a lecture, probably in Sweden, I'm guessing, and you get to go to dinner, you get to do all sorts of fun things. But this was the beginning of his Nobel lecture when he won the Nobel Prize in economics. And I just want to read the first paragraph because this gives us a hint as to exactly what we're going to be talking about in this section. The world economy, like the economy of a single country, can be visualized as a system of interdependent processes. Each process, be it the manufacture of steel, the education of youth, or the running of a family household, generates certain outputs and absorbs a specific combination of inputs. Direct interdependence between two processes arises whenever the output of one becomes an input of the other. Coal, the output of the coal mining industry, is an input of the electric power generating sector. The chemical industry uses coal not only directly as a raw material, but also indirectly in the form of electrical power. A network of such links constitutes a system of elements which depend upon each other directly, indirectly, or both. So here again in linear algebra, we get to see the power of linear algebra in taking really complex systems and being able to order them, to structure them, and to answer questions that wouldn't be immediately obvious and would be really hard to detect if we didn't have the field of linear algebra. So the first idea we need to introduce is this idea: the production of commodities by means of commodities. Okay, what does that mean? So say that we have an economy here, and you have a lot of different inputs in your economy, and one of your inputs is steel. And steel will be necessary to produce a lot of outputs of your economy. So a certain amount of steel will go into your transportation sector, and we can think of another sector like construction. And there's a certain amount of steel that feeds the construction industry. And you've got all these different sectors in your economy, and we're looking at how much steel goes into each sector. And one of these sectors is actually going to be steel. It takes steel to make steel. And so you're going to have a certain amount of steel to feed the steel industry. So maybe some of these other sectors are agriculture or education. And so if you think of all the things listed here as inputs and all of the things listed here as outputs, you can see that steel itself is going to require, different inputs from the economy. So for example, how much in the way of transportation are you going to need to produce steel? You're going to need something. And how much from the construction industry are you going to need to produce steel? So different industries will all go into producing steel. Where steel was important to produce all things in all of these industries, a lot of those same industries are necessary to produce steel. So in a matrix like this, you can start to really organize the interdependence on all of these different parts of the economy. And say that you wanted to, add all this up, and it would be the output of steel. Say you wanted to double the output of steel. How does that affect different industries? Or if you wanted to double steel and cut something else in half, you're able to sort of quantify that interdependence. So this is what is meant by the phrase, it takes commodities to produce commodities. And this particular example comes from David Harvey, who's a professor at City University of New York. So let's think of a way to put actual numbers in this matrix. And we've still got steel as among our inputs, and we're looking at transportation, construction, and steel as our in the list of our outputs. And maybe this is a good way to decide how to put numbers in here. To produce $1 worth of transportation, or $1 worth of construction, or $1 worth of any of these industries, including steel, how much would it cost? How much steel will it cost to produce $1 worth of transportation? And so there'll be plenty of numbers all through this matrix, but thinking about this one right here, this 0.21, that means it'll take 21 cents worth of steel to produce $1 of transportation commodity. And it'll take 28 cents worth of steel to produce $1 worth of construction. And it'll take 8 cents worth of steel to produce $1 of steel. So in a general sense in this matrix, what does Aij represent? Aij would be the amount of commodity, let's see, I is the row, so the amount of commodity I needed to produce $1 of commodity J. So again, this 28.28 is representing that we need 28 cents worth of steel to produce $1 of the commodity from the construction industry. And we are simplifying here a little bit in that we're saying that each industry has this, generic output. But this is the convention that we'll use throughout this section. So these numbers, it'll be important to remember, when we see something in the 7th row, 3rd column, what exactly that represents, which one is the input and which one is the output. And this is another example from your textbook. This is actual data from 1972 of the U.S. economy, and this is not the whole matrix. This is just a part of it. It goes on for 79 columns, 79 rows. But this example shows us some of the industries: livestock, agriculture, forestry. And so when it says that A72 is this number, 0.00002, that means that to produce $1 worth of agriculture crops, we needed $0.00002 of coal mining inputs. So these input-output matrices are real things that are used. So one question we can ask is, can we have an economy where, first of all the demands are met? All industries that need things are able to get them. And secondly, that we don't have a lot of extra stuff. So like no leftover would be ideal. You don't want to have billions, not billions, but millions of pounds of leftover steel that can't be used by anyone, just kind of clogging up the country. And then there's one other idea I need to talk about. There's all these sectors that are, taking inputs and giving outputs. There are certain sectors that just suck inputs and don't really give an output. You can think of them as non-producing sectors. Like, for example, consumers or governments. They're not really producers, but they're consumers of these products. So we will have some of that, and those sectors are called the open sector. So when we use the phrase open sector, we know we're talking about that part of the economy that does not produce anything but does consume some of these inputs. Okay, we're going to try to better understand these Leontief input-output models by looking at say a country only had 3 industries, or you can think of them as 3 commodities or 3 sectors, like steel, agriculture, and one other thing like transportation. Okay, so and remembering all along that an entry in this matrix, so the Aij entry, so like the A2, let's say the A13 entry, this means that we need 40 cents of commodity 1 to create $1 of commodity 3. So this is our key for understanding this matrix. And we're going to answer a series of questions about this country, and we're going to go from easier to harder. Okay, so we have these 3 questions. These are some of the easier questions we're going to see today. And I want you to go ahead and pause the video and see if you can fill out these 3 blanks, answer these 3 questions about this industry. Okay, how much of commodity 1 are required to produce $1 of commodity 1? That's this entry right here. So it looks like it takes 20 cents or 0.2 of a dollar to of commodity 1 to create $1 of commodity 1. So this was analogous to how much steel did it take to produce $1 of steel. It takes other things to produce steel, but you're going to need some steel to produce $1 worth of steel. Next question, how much of commodity 1 are required to produce $1 of commodity 2? And that's this number right here. So again, 20 cents, and we'll answer this one. How much commodity 1 are required to produce $1 of commodity 3? It takes a little bit more of commodity 1 here. It takes 40 cents or 0.4 of a dollar to produce $1 of commodity 3. Okay, we did a good job getting our feet wet with these easy questions. Let's move on to some questions that are a little more difficult. Okay, our first question, suppose the economy produces $99 worth of commodity 2. So we're not producing $1 of commodity 2 anymore, we're producing $99 of commodity 2. How much of commodity 1 goes into producing that $99 of commodity 2? Okay, I want you to go ahead and pause the video and think through this question and the next one and see what numbers you come up with. You'll definitely learn this material better if you're, taking guesses and trying things along the way, rather than just watching me present everything. So go ahead and try to fill out these 2 blanks here. Go ahead and pause the video. Okay, so we're creating as an output commodity 2, and we're wondering how much of commodity 1 goes in if we need to end up with $99 worth of commodity 2. So we know that for $1 of commodity 2, we need 20 cents of commodity 1, so we're going to multiply that by 99. And when we multiply those, we get that it takes $19.80 worth of commodity 1 to produce $99 of commodity 2. There's other things going into commodity 2, but that's the portion of commodity 1 that we need. Suppose the economy produces $156 worth of commodity 2. How much of commodity 1 goes into producing the $156? Okay, same story. We're going to multiply by 156 of however much of commodity 1 goes into just $1, and we'll get our result. And this time we get that it takes $31.20 of commodity 1 to produce this much of commodity 2. Okay, I moved things around a little bit, and we're going to ask one more series of questions with this guy, and we're going to get even a little bit more abstract. But you can see where I'm going with this. Not too hard, a little bit tougher here, but we were still able to answer. Let's see what comes next. Okay, this time the questions are a little more abstract. And our first question is, suppose the economy produces $2 worth of commodity 2. How much of commodity 1 goes into producing $2 worth of commodity 2? So instead of getting specific numbers for how much of commodity 2, we're using this variable here. And then asking a similar question for how much of commodity 2 goes in and how much of commodity 3 goes in. So go ahead and pause the video, take a minute, and take a stab at these questions. I bet you'll be able to answer them. This time our answers will have some variables in them, but it really is following along the lines of what we've already seen so far. So go ahead and pause the video here. So I hope you were able to get the answer here. Again, your learning is going to be way better if you're answering the questions instead of me answering the questions. Okay, so we have $2 worth of commodity 2, and I want to know how much of commodity 1 goes into that. So it's $0.2 for every $1. So for $2, it seems like it should be 0.2, or we can say $2, that many dollars, times the 0.2 that's coming from commodity 1. And you can clean that up if you want. 0.2x2, this is it. Similar for commodity 2, we know that to produce $1 of commodity 2, Well, this is a good point to stop and say, do we know which way to go here? How much of commodity 2 goes into producing, so how much input of commodity 2 goes into producing an output of commodity 2? And that would be 0.6 of a dollar. So if we had $2, then this one should be x2 times 0.6. So 60 cents, or 0.6 x2. And the last question, if it's producing $2 worth of commodity 2, so that's the output, the commodity 2 is being produced, so all of these numbers are important here, then how much of commodity 3 goes into producing that amount of commodity 2? It turns out the input from industry 3 is $0 for an output of commodity 2. So nothing goes into from, this is like maybe there's no farming that is required to produce steel or something. So no amount of commodity 3 goes into producing that x2. So here we have that x2 times 0. So that's just $0. And I should say each of these are dollars also. So this is a series of questions that you want to feel really comfortable understanding what we did here. So if you need to rewind and watch that again or think through that again, that's a good idea, because we are going to actually take it one more step in abstraction. So first, make sure that you're really understanding what happened here. Okay, this is kind of our final level of abstraction for this part of the example. Using just aij's and xi's, so no actual numbers, represent each product above. So this product, this product, this product. So where do these numbers come from? Let's see, this 0.2 was this element here. So go ahead and try to fill these out. Where did each of those products come from using just aij's and xi's? Go ahead and pause the video and fill out these 3 spots yourself. So we could say that that first product, this product right here, that came from, let's see, the 0.2 was A12 times x2. And then that second product, the 0.6, came from A22 times x2. And then that third product was that A32 element, so A32x2. Okay, I'm glad you've been filling things out as we've been going along instead of just watching me answer it, because as we go along, we're going to add even a few more elements. We're next going to add some of the demands of the open sector. And remember, the open sector were these consumers that don't produce anything. Maybe they're actual, people consumers, or maybe they're governments that need resources but really don't produce any resources that other industries would use. So if you need to, before we move on, just pause and make sure you're understanding the flow of all this so far. And before we go on to the next step, we're going to call this, all the work that we did here, Leontief InputOutput Matrices Part 1. And now we'll go to Part 2. So now we actually know a little bit more. We have same matrix, same info we had in Part 1, but now we know that the demands of the open sector, these consumers that don't produce anything but still need things from different industries, the demands are represented by this vector right here. And so we'll talk about what each of these numbers means. So the open sector, all those entities that don't produce anything, they need $9 worth of industry or commodity 1, they need $12 worth of commodity 2, and they need $16 of commodity 3. They need that just given to them. They're not going to contribute anything to producing any of the commodities, but they need these. Those are the needs of the open sector. And we're now going to define a variable. We kind of used it in the last page, or the last part. Let x1 be the amount of commodity 1 that the economy needs to produce so that all the industry's needs are met, the open sector's needs are met, and there's no leftover, so there's no extra commodity 1. So this is kind of an ideal situation. So we're going to define this variable, and it's similar for x2 and x3, where this is the ideal amount of commodity 1 that this economy is going to produce. So the way we're going to think of it is x1 is the total output of commodity 1 to have all these awesome conditions met. It's like the most efficient way for this economy to run, that there's enough commodity 1 that, you know, commodity 2s and 3 can still be produced, the open sector gets what it needs, and that there's not a bunch of extra commodity 1s sitting around the country. So it's just there's no extra. This is the ideal situation, and we're going to try to optimize that. So we're about to answer a bunch of questions here, but I want to just collect all of the variables that we've talked about so far. So from the beginning, we know that Aij in this matrix is the amount of commodity I in $1 of the commodity J output. And then, maybe I haven't said it explicitly, but DI, we're going to call that the demand of the open sector from industry I. And then what we just talked about here, XI, or we used X1 up here, but XI in general is going to be the total output of industry I necessary to meet demands of all the industries and demands of the open sector. And just put another way, XI is the total output of industry I necessary to meet all industries and open sectors needs, and hopefully won't have any left over. Okay, so this is, we know what all of these variables mean at this point. A lot of theory, a lot of abstraction, but we are building up to a big abstract idea that we can use in some practical examples. Okay, so now that we know this, let's answer some more questions. Okay, we're going to think about industry 1 for a minute, and A11X1, let's ignore this just for a minute. Let's think about A12X2. And let's describe what this is in words. And we're going to remember some things that we learned down here. So, remembering, and A12 would be this right here. Let's see, A12 is this right here, times x2, and describe this in words. So go ahead and pause the video and try really hard to do this on your own. You'll learn it way better if you write something down, take your best guess as to what this is. So this is going to be the amount of commodity 1 needed to produce all of commodity 2. Okay, so A12 times X2 is the amount of commodity 1 needed to produce all of commodity 2. And so go ahead and describe all of these in words and describe this guy in words. And do this on your own. Go ahead and pause the video and do all that on your own, and we'll see if we get the same thing. And so I'm sure you got this right. This expression right here describes the amount of commodity 1 needed to produce all of commodity 3. The total amount of commodity 3 that this economy is going to need, how much of commodity 1 goes into that, is expressed in this right here. And this expression right here, A11 times X1, describes the amount of commodity 1 needed to produce all of the commodity 1 that the economy needs. And so just be sure that you fill this part out before I hit it. Take your best guess as to what this right here represents. It's not too hard since we've got it up here. So just as it was defined up here, this is how much of commodity 1 that the open sector needs. Those guys that aren't really producing anything but still need some of these commodities. All right, thanks for hanging on with me through all of this. We're going to put all of this together in a minute. But just wanted to be sure that we understood what each of these pieces describe. What would happen if we added all of these up? What does that describe? Okay, so this is definitely our big question right here. What does all of that added up together, what is that representing? If you took the amount of commodity 1 needed for this guy, for itself, for the open sector, and added all that up, how would you describe this? There's actually a really short way to describe it. But go ahead and fill this in and see if you can figure it out. So hopefully you paused the video and filled something out here. But basically, this is just all of commodity 1 that's needed by everybody, whether it's, you know, itself or other commodities or the open sector. This is representing all of what's needed for commodity 1. So why didn't I write this right up here? Because there's a much shorter way to describe this phrase. All of what's needed of commodity 1. Let's see, XI is the total output of industry I necessary to meet all industries and the open sector's needs. So isn't all of this just the quantity X1? Yep, so that's it. All of this added together equals all of the necessary X1 that we need for this economy. Well, so this is a interesting, X1 shows up here, but it also shows up here. Okay, so this is what we just decided on the last page. Ooh, I see an error here. This should be 1. So let's change that. D1. This was just all the amount of X1 needed for the economy. This is what goes into producing X1. This is what part of X1 goes into producing X2, what part goes into producing X3, and what the open sector needs of X1. So the next thing that you should do is try to describe industries 2 and 3 similarly. So you'll have X2 equals, well, let's see, what would it be? I'll get you started. It would be, this is the amount of commodity 2 needed to produce commodity 1 times how much of commodity 1 we need, and keep going and produce a similar equation as to what we did for commodity 1. And then do the same thing for commodity 3. So go ahead and pause the video. I'm hopeful that this is what you came up with to describe industries 2 and 3 or commodities 2 and 3 similarly, that the total amount of the second commodity that we will need is the combination of all of these things. You know, how much of the second commodity goes into all of the X1, all of the first commodity that you want, how much of that second commodity goes into producing all of the second commodity you want, and so on. And then how much of that second commodity is demanded by the open sector. Similarly for X3. So I know that there's so many numbers and, you know, these little subscripts and different letters, and it looks just like, whoa, just so many letters and little numbers. But these all have deep ideas and deep meanings behind them. So we've taken the time to go through this to appreciate the really remarkable ideas that we're just on the cusp of really grasping the kind of big ending here. So I'm going to ask you a couple more questions. At this point, we have essentially 3 equations. And what I'm going to ask you to do is write the system of equations using matrices. So these 3 equations, could you write them in here? I want you to pause the video, but let me give you a few hints first of all. This equal sign, you know, here's a few equal signs, and boy, it looks like there's something that would really fit well into this matrix on the left side of the equal sign. And then this might be the trickiest part, but then, oh boy, this plus this vector, and here we have plus this kind of thing here. Now, think through what should go in here. So pause the video and try really hard to fill in this matrix equation here. Okay, you probably already know that the x1, x2, x3 from the left side of the equation goes in this vector, and this d1, d2, d3 is this part of the equation, or the system of equations. Now, all of this information we want to get into these last 2 matrices. So we have a bunch of a's. How many a's do we have? We have 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many x's do we have? We have essentially 3 x's. So we're going to probably put all the a's in here, and put all the x's in here, and we need to make sure they get multiplied in a way to create this part of the equation. And so this is how these equations should look. And if you do the multiplication here, you'll get this first part of this top equation, and so on. Okay, so remember, this was given to us. This is that input-output matrix that's initially given to us, and this was given to us. These were the demands of the open sector. And really, essentially what we're looking for is we're trying to solve for x1, x2, and x3 here. A lot of times we call matrices by these capital letters. I want you to give each of these a capital letter and create a new kind of simple equation. No matrix boxes anymore. Just use capital letters and write this equation here. Go ahead and pause the video and come up with your equation. Okay, so maybe what you came up with is something like capital X equals A X plus D. And this right here was the given input-output matrix. This was the given open sector demands. And then these x's, it's the same x. It's, just x1, x2, x3. This is what we're looking for. So we don't know this, and we're looking for it. And it's the same guy here. Same x. Okay. We're almost at the end, and all the work you've done along the way, you've all almost earned your Nobel Prize, because we're just going to take this guy a little bit further. So this is the equation that we came up with just a minute ago, and it represents that the total output needs to equal the inner industry portion of output plus the open sector portion of output. And what I'd like you to do is solve the above equation for x. And because all of these are matrices, we need to be really careful that we only do operations that are allowed with matrices, and watch for whether those things should be right multiplied or left multiplied, since there is a difference. So pause the video and solve this equation here for x. So we definitely can say this. We'll just we will subtract ax from both sides. And this is similar to real numbers. You want to collect any terms that have that x that you're looking for in them. And this is totally legal to do with matrices. You can definitely subtract the matrix ax from both sides. The only tricky part of this whole process is the next step. We want to essentially factor this x out. And so we have to think about, where does the x go? Does it go on the left or the right? Because matrix multiplication is not commutative, we have to be really particular about how we factor this x out. So how do you feel about this here? Think about multiplying this back in, and we would get Ix, which is just the identity matrix times x, which is x, minus a times x, which is what we had before, and it's in the right order. So this looks about right. The only thing left to do is we want x by itself, so we've got to get this matrix, moved over to the other side of the equation, and we can't just divide by it. You can't really divide by a matrix, but we will use the inverse. We'll take the inverse of this matrix and multiply both sides by that inverse. So we have this inverse, which is good. This is going to create the identity matrix over here, which is just what we want. And we will have all this stuff over here, but we'll just keep that hanging around. And so here we got the identity matrix, because an inverse and a matrix and its inverse will multiply to the identity matrix. We can drop that guy off because Ix is just the same as x. And then x equals all of this. And this is the grand prize. This is what you win the Nobel Prize for, is this relationship right here. Here is what we're looking for. How much of all of these different commodities do we need to make to optimize the economy of the nation? And all we have to know is what does it cost to produce a certain commodity? How much of each commodity do you need? What's the demand of the open sector? And then this is your answer according to Leontief. And so, bam, this right here, this guy, this whole equation here, this is what you win the Nobel Prize for. And which Leontief did in the 70s. I don't know if you really wear it around your neck like this, but that's a big deal. This is the Nobel Prize in Economics, and it was for essentially these input-output models. I do want to make one more note. This D, which is essentially this is the total output and of the economy, and you're subtracting off sort of all of this stuff that the industries themselves are going to take up and use to create the things they need to create. So that total output minus what's being kind of reinvested back in, this is the gross domestic product. So you'll hear that. Actually, I think it's the gross, there's a slight difference. This is gross national product. So when we see this D, we know that that is actually gross national product of a nation, of an economy. So that's just a little add-on that happens to be, if it's in a national economy, that's the gross national product. Okay, but this is the like real show stealer here. One thing I wanted to note before we move on is that this matrix I minus A does need to have an inverse. If it doesn't, then that implies that it's, we can't solve for X. It's not solvable. That there's not those levels of output that would make the whole situation work. So then that is possible, that maybe you have industries that are too, it's too expensive to make steel with all of the inputs. And so it is possible to have an economy that's just not going to work out. If your numbers in the original A matrix are out of kilter, are not sustainable, are not going to work out, then it's possible that you can't solve this equation. Okay, we're going to take a look at this example. We have an input-output matrix for an economy. So for example, let's take this guy here. To produce $1 of commodity 3, we're going to need 20 cents of commodity 2, this entry says. And over here, we have the demands of the open sector. So this tells us what A and D are, which we just went over. Find the output levels required of each industry to meet all these demands. So we want that X1, X2, and X3. That's what we'll call them. So that all of these demands are met, that the open sector gets what they need, and the industry is, the economy is able to generate enough of each of the commodities to produce the other economies and also meet these demands here. So we're going to use this model here, which we just spent gobs of time figuring out what all this means. And the X is what we're looking for. Identity matrix, we know what that is. We have matrix A and we have matrix D. A little bit of work is going to be, finding this inverse matrix. So here it is. We just need to figure out all of this, and this will pop out of this will be what we need for each commodity, how much of each commodity we need to produce. So we'll go ahead and take this. So I've done the subtraction. I do need to find the inverse of this matrix, and we have gone over how to find one way to find the inverse of a matrix. I'm just going to let my calculator do it now. You can essentially enter this matrix into your calculator and then just use really the power button, this -1 button on a TI, and that will find you the inverse matrix. Okay, so the inverse of that matrix ended up being this guy right here, and I'm going to take this and multiply it by our open sector demand vertex, or not vertex, vector. And when I do this multiplication, I'll get another vector, and this will tell me how much X1, how much of commodity 1 I need to make, how much of commodity 2 I need to make, and how much of commodity 3 I need to make. Okay, so I've done the multiplication, and this is what I've come out with, that I need to make dollars. We'll assume that these numbers up here, that this big economy doesn't need just $4 worth of commodity A. Maybe it's like millions of dollars. So these numbers represent the necessary output level of commodity 1, commodity 2, and commodity 3 in millions of dollars.